a diagonal of a parallelogram divides it into two congruent triangles. Okay, diagonal of parallelogram divides it into congruent triangle. I've given you this as a property. Okay, and we now discuss the proof of this property. Now, whenever you are doing the proof of such properties, okay, it is customary to always write what is given and what you need to prove. Okay, so first we will see what is given here. If you see what is according to a statement, you read the statement and then see what is given. Diagonal of a parallelogram. So what I say is ABCD is a parallelogram. Given here, ABCD is a parallelogram. Okay, that is the only thing that is given. Okay, and then next thing is we draw the figure. Draw the figure. Draw a parallelogram. Okay, and draw the diagonal. You have ABCD as your parallelogram. Okay, and one diagonal you already draw. You either draw AC or you can draw BD also, no problem. Okay, now you see what you have to prove. To prove here that these two triangles are congruent. Triangle ABC congruent to triangle ACD. Okay. So these two triangles we need to prove congruent. Now we proceed with the proof. So see, how do we prove first? So first, since it is a parallelogram, these two are parallel, marked in the figure. Okay, you mark it in the figure. Now, in order to prove congruency, what you see is that these two angles are equal. This angle is equal to this angle. Okay, and these two angles are equal. Why? Because they are alternate angles. Okay, and what you see is that this side AC is the common side. Okay, so therefore, by what axiom can I prove congruency?
Yes, sir.
Sir, angle side. No, sir, angle.
Yes, exactly. Angle, side angle. Because if you see any of the triangle that you take, suppose I consider this triangle, you see that this angle is involved here, this one, and this angle is involved, and this included side is involved. Okay, this is the included side between these two angles. Therefore, angle, side, angle. So very quickly, let us complete this proof in writing. So in triangle ABC and triangle ACD. AC is equal to AC because it is the common side. Next, angle, the red angles, angle ACB is equal to angle BAC. Okay, and I'll give you a reason, alternate angles. angle. Even if you see the table is drawn here while doing the proof, you don't need to draw the table. You can do what I am doing. Okay, tables are not required here. Angle CAB is equal to angle ACD. Again, reason alternate angles. Therefore, triangle ABC congruent to triangle ACD. This is by ASA axiom. Okay, and this is what we needed to prove, that these two triangles are congruent. So we finish the proof. Okay, so very small proof. Next one, all these proofs are actually small. Next theorem is, in a parallelogram, opposite sides are equal. Okay, right? In a next theorem is, in a parallelogram, opposite sides are equal. So what is given here? Again, it is only given that ABCD is a parallelogram. Okay, you draw the parallelogram. Let us redraw the parallelogram without the diagonal. Maybe a fresh diagram. Okay, and call this ABCD. These two are parallel.
Excuse me, sir.
Mhm.
Sir, I have a question.
Go ahead.
So, in the question paper, the theorems will be given and we will prove it.
Yes, yes. The statement will be given. This statement that is there in the beginning that I am writing, the statement will be given.
Yes, sir.
So you have
Thank you.
you need to show that the opposite sides are parallel. Okay, so this is our parallelogram. We have drawn the parallelogram, and let's see what we have to prove. We have to prove here that AB is equal to DC, and you have to prove AD is equal to
BC.
DC. Okay, so how do I go about proving? Now, before proving, you have to just write one construction here. Okay, that is, you join the diagonal. You have to do this construction on your own. Join this diagonal AC, or you can join BD also. You join this diagonal and you write here. Before proceeding with the proof, okay, you write here, join AC. Okay, now exactly in a similar manner, we prove that these two triangles are congruent. Why? Because, again, let me just mark here, these two angles are equal. These two pair of angles are equal, and obviously this is our common side. Okay, so therefore these two are equal, exactly as we did the last proof. Okay, so you'll continue this proof in this manner here. Okay, you'll prove these two triangles are congruent, and after this, what you see here is that once I've proven that these two triangles are congruent, I can say by CPCT that this side is equal to this side, and this side must be equal to this side. Can I say or not?
Yes, sir, you
Yes,
can
sir.
say.
Because opposite to the red angles, opposite to these red angles, you have this side. So these two must be equal. and opposite to these green ones, you have these two sides. Therefore, they must be equal. So exactly in a similar manner, this part remains the same. You have to prove the two triangles to be congruent, and here you just have to add AB is equal to DC and AD is equal to BC. This is by CPCT. Okay. So proof of these two theorems are exactly the same. Next theorem is, if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. This time, just write the proof here. Let's write the theorem. If each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Okay, so first let's see what is given here. If each pair of opposite sides of a quadrilateral, so I have given to you a quadrilateral. ABCD is a quadrilateral, any quadrilateral. Okay, you have to show that this is a parallelogram given that the opposite sides are equal. So let us first draw this parallelogram. Not parallelogram, in fact a quadrilateral. Any quadrilateral which looks like a parallelogram somewhat. Okay, and we will not we will not write the parallel sides because it is not a parallelogram. Okay, and we'll write to prove. Okay, not only that, ABCD is a quadrilateral in each pair of opposite sides are equal. So not only this is given, ABCD is a quadrilateral, but also that opposite sides are equal. These two are equal. So AB is equal to DC and AD is equal to BC. Okay, these two are equal. To prove ABCD is a parallelogram. How do we proceed with the proof? Before writing, okay, let's see how we can proceed with the proof. Again here, what you do is you join the diagonals. You first write join AC. Okay, so now what you do is you join the diagonals. Join the diagonals of this parallelogram. Okay, now what we are going to do is we are going to prove that these two, in order to proceed with the proof, we are going to prove that these two triangles are congruent. We're going to prove that these two triangles are congruent again. But this time, what is given to us is different. This time, unlike the proof that we did earlier, ABCD was a parallelogram there. Here, ABCD is not a parallelogram. Here, ABCD is a quadrilateral. Okay. So what you do here is, in order to prove that these two triangles are congruent, see that these two sides of the triangle are equal, AB and DC. Right? AB and DC are equal. It is given to you. Again, these two sides are equal, AD and BC. Right? Also, AC is the common side. Right? So therefore, these two triangles are congruent by SSS axiom. Okay, side, side, side. So once I have proved the congruency of these two triangles, I want to show that this is a parallelogram. In order to show that it's a parallelogram, I just want to show that this side is parallel to this side, and this side is parallel to this side. Okay. So once I have proved congruency of the two triangles, now what I'll do is I will say that these two angles are equal. Which two angles?
Excuse me, sir.
Yes.
Sir, how can you say that the sides are equal?
It is given to you. In
No.
ABCD is a quadrilateral in which opposite sides of quadrilateral are equal. So I've written here AB is equal to DC, AD is equal to BC. Okay.
Okay, sir.
So these two are equal. Therefore, I have proved these two triangles congruent. Now what you see here is that this angle is opposite to this side. So it must be equal. These two sides are equal. Therefore, these two angles must be equal. Right? But you see that these two angles are alternate angles. Therefore, this side must be parallel to this side. Also, you see that these two sides are equal. Therefore, these two angles must be equal. This angle must be equal to this angle, right? These two angles must be equal. But these two are alternate angles. Therefore, this must be parallel to this side. Is it clear?
Yes, sir.
Yes, sir.
So that is what. We proceed with the proof in triangle ABC and triangle ADC. AC is equal to AC, common side. Next, AB is equal to DC, given, and AD, in fact BC is equal to AD. This is also given. Okay. Therefore, triangle ABC is congruent to triangle ADC by SSS. And therefore, what can you say? The red angles are equal. That is, therefore, angle ACD. Well, let's say, since I've written ABC first, so let me write the angles of ABC first. Angle BAC is equal to angle ACD, because by CPCT. But these are alternate angles. And therefore, AB must be parallel to DC. Also, the green angles here are equal. Okay, that is angle ACB is equal to angle CAD. again by CPCT. Again, but these are alternate angles. Therefore, what are the two sides here? AD parallel to BC. Thus, it has been shown above that ABCD is a quadrilateral in which the opposite sides are parallel. Hence, ABCD is a parallelogram. Okay, so this is proved. Fine.